Hey guys, this is this is a supplemental video to help you with some of the pictures. Now in the homework, it's going to ask you a few things. I'm going to just look at a sample here. So, okay, so if you had, let's say a situation like this. Okay. Remember, this is out of, this side is into. Okay, so out of, into. So what's happening is the B field, if this were a flat surface, the B field would be running out of this, like this, and into that. Out of this, into that. So let's take a look at what that looks like in terms of our right-hand rule. So let's just hold our thumb up just arbitrarily. And I think this is going to end up working. Okay, this is the direction of the field. They ask you to draw a little line here, an arrow to show the direction. This is our right-hand rule. So if I look at this, out of, out of, out of, that's out of the left side, and then it wraps around, and I can't like put my hand like into my hand, but out of, and then into, out of, into. So that means the direction of the field is up. Okay, so I would end up drawing a nice big arrow right like that. So that is a wire. So our current is here. The B field wraps around into this side. Okay, so you can see that. So there's also some other things that you're going to see, some other diagrams. And they, instead of drawing the B field, they're going to draw like an X like this, and they're going to put a circle around it. Okay, so X represents what? Into or out of? X is into. Just remember, the X or the plus sign is into, and this represents the tail of the physical arrow feathers. So look, if I go into, that means my thumb, it's going to be hard to see this, but my thumb is going this way, down. So my fingers are going to wrap around this way. So they want to know the direction of the field, and you end up drawing lines like this. Okay, so remember, into, and then I take my hand and I'm going into, and I curl my fingers around to the right. So the answer here would be these arrows here. Okay. So similarly, let's say they said here's the current, and they draw this field around it. Okay, and they want to know what that looks like. So this is, again, we know out of. Okay, it's our Z dimension. Out of, that means your thumb's facing up, and so what's going to happen is, out of means that it's going to curl around this way. So the B field will curl around this way. Okay? And another piece of terminology that I'm seeing on the homework is it's about a compass needle. So they show this as the compass needle, and they kind of expect you to know that this represents a compass. So let's take a look. You've got this. Okay, that is going into. Okay, that's into. So if I take my thumb, I'm going into that. Okay, the direction of the magnetic field, okay, will go this way. Okay, so look. Okay, the direction, my thumb is facing into, the direction of the field is this way. So they just want to know like what orientation this will be in. And remember that we said that the magnetic field lines, specifically flowing out of a magnet, but also in this situation, are going from the north to the south. So what happened is this, your thumb's down like this, and then you curl around like this. Okay, the field travels from north to south. So this would be labeled south, and this would be labeled north. Okay, north to south, and that's where this bit of terminology comes in. And if I do one that looks like this, okay, and I don't know why they put a circle around it, but I'm gonna leave the circle off. I think the circle is confusing. So here's what it is. We know that this is out of. Because that's out of, that means it's shooting out of the paper. That's your thumb. It's spinning in this direction. Okay, and what they're saying is, here's your compass needle. We know that it flows north to south. So what I would have on this side would be a south and then a north, because we know it goes from north to south. Okay, so that's how that works.